today I would like to talk about the key success factors of a financial incentive program for efficient electric motor systems. And to give you an overview about the content of today's presentation, first, of course, a short introduction. Then I would like to talk about the instrument for the competitive tenders in Switzerland and the brief evaluation of this instrument. Then we look into the key success factors, proceeding to considerations about a program design and building blocks of a successful financial incentive program. This will be followed by looking at different modalities for subsidies, and finally, the energy efficiency obligation scheme for electricity suppliers. And of course, at the end, some conclusions. I should be able to move to the next slide, but I'm not. Okay, now, introduction. I think everyone on this Motors Academy is very familiar with the world of electric motor systems. So this is just a very brief reminder of how big the total final electricity consumption attributed to motor systems is. And this is, in the industrial sector, a very dominant share. So electric motor systems represent 74% of the electricity consumption in the industrial sector worldwide. And apart from industry, motors are mainly used in large buildings and infrastructure systems, but also in transport, agriculture, and household appliances. So we are talking about a significant share of electricity consumption. When we look at the complete motor system, of course, we have different components. And this is just a reminder that the savings potential, the average savings potential on a system level are between 20 to 30%. And of course, if we are optimizing only at a component level, the savings are significantly less. So whenever we're talking about electric systems and optimization, we always keep in mind that the system level is where the highest savings lie. Now going to the policies for electric motor systems in Switzerland. Now I distinguish between three categories of policies, namely the minimum energy performance standards, which are basically in sync with the EU requirements for motors, pumps, circulators, fans, and variable speed drives. So all the minimum requirements that exist in the EU are applicable to Switzerland one-to-one. Then another part of the policy instruments are centered around awareness raising and capacity building. And finally, what we will talk about today are the financial incentives, and the policy instrument for this, for motor systems, is the competitive tenders. And these competitive tenders are being in effect or are ongoing since 2010, so quite a significant amount of time. I have some issues with going to the next slide. I don't know why. Okay. So the Swiss competitive tenders, a brief overview. As mentioned, they are running since 2010. The overall goal is to save electric energy in the sectors household, industry, and services. The budget is currently around 50 million euro per year, and the procedure is a tender, as the name says. So bidders can apply a project for a project or a program to be financed in the framework of these competitive tenders. A project is for one facility, for one project, and the program encompasses several projects. So it's a combination of several projects, and it's usually led by a third party, by a dedicated third party who is managing that particular program. What is important to mention is that the criteria for getting the funding for these programs and projects is the cost effectiveness. This is the main criteria. which means the amount of subsidy per amount of energy saved over a lifetime of equipment. This needs to be very favorable in order to get the funding. There are also some other requirements. For example, the subsidy can be only or maximum 30% of the investment costs, and you can check out the website for more information. Some results of this competitive tender program to date. There have been 956 projects and programs implemented, a total of 1,020 gigawatt hours per year of electricity saved. And this equals to 14.5 terawatt hours of electricity saved over the lifetime of the newly installed equipment. The average cost effectiveness was around 3 euro-cent per kilowatt hour saved, and a total of around 430 million euro subsidy was already given for these projects and programs. So it is a significant program. Now, before we proceed, actually, there should be a slide for, where is this slide? For the first poll. So I will ask my colleagues for help here, because the first poll should be launched now. And I am not sure where my slide for that has disappeared. In any case, I would like to invite you to participate in a poll. There will be a total of 4 polls during the course of the webinar. And here the question is, what do you think? Which applications delivered the highest savings for the motor systems? Fans, pumps, circulators, air compressors, cooling compressors, motors, variable speed drives, or mechanical processes? And here is my poll. Actually, while you're voting, I could just briefly show you this slide on the savings per technology, because the savings did not encompass only motor systems, but also other technologies. The highest share of the savings was in motor systems, and we will see soon which particular applications delivered the highest savings. The second highest savings were delivered by lighting. The third category was other. This was followed by various technologies, and you can see at the bottom of the slide all the different other things like the other building equipment, warm water, household equipment, process heat, transformers, and so on, that delivered the total savings. As for the motor systems, in total, we had 3.2 terawatt hours saved over the lifetime of the newly installed equipment, which translates into 205 gigawatt hours per year of savings. And this was 29% of the total savings between 2010 and 2021. These savings figures, they apply to programs and projects together. And by now, I hope you had enough time.
Sorry, Rita, you seem to have muted your microphone incidentally.
Oh, wow. I'm sorry. Thank you.
It works.
Okay, I hope, I don't know how much you missed, but okay. So now the result of the poll, people seem to believe that motors and variable speed drives delivered the highest savings, followed by air compressors, pumps, and fans. Now let's see how it truly was. Okay, so cooling compressors delivered the highest savings during the course of the program between 2010 and 2021. This was followed by circulators, mechanical processes, fans, air compressors, and finally electric motors and variable speed drives gave only a little share of the savings. Why is that? Now, here are some answers to this question. So the savings, they largely depend on the type and the success of the individual programs and projects, meaning programs that were targeting cooling compressors, circulators, mechanical processes were quite successful and delivered savings, while programs that were targeting, for example, pumps, they were hardly present. So therefore, not so much savings. And in terms of motors and variable speed drives, it's a little bit the same, although there is also another aspect, which is how deep into the system optimization the programs really went. We will talk about this a little bit later. So this slide is to present you the study that was mentioned in the beginning. So a feasibility study for a financial incentive program targeting electric motor systems in Switzerland was just recently published this year. The report is in German only. However, today you will hear the key findings in English in this webinar. And the report is something like a summary of brainstorming or ideas based on the evaluation of the current Swiss competitive tenders program and on factors that we believe are crucial for the success of a financial incentive program. So in order to make this evaluation, we, together with our colleagues, analyzed 14 programs that were also targeting electric motor systems within the framework of the competitive tenders and conducted expert interviews with the program managers. This was complemented with data analysis from the programs, and this is the basis for the evaluation of these programs that I will show you in the next slides. So first, a little bit about the program characteristics. We can distinguish between different programs in the sense that they are either technology or target group oriented. And even so, they can have a different focus. For example, an application focus, like for circulators, fans, compressors that I mentioned before, or a system optimization focus, which then includes subsidy for analysis, measurements, and the concrete improvement of equipment. Of course, this is part of every program, the improvement of equipment. But for the rest, we will see that there is a diversity in programs. In terms of the target group, it can be a select group. For example, in Switzerland, there is a voluntary target agreement scheme, and some programs are dedicated to participants of this scheme, or the other programs are dedicated to specific sectors. One example is the gravel, hard stone, concrete, and surfacing plants. So one program is dedicated to this particular sector. As for the analysis, there are, for the optimization of motor systems, since they are very complex, usually they need some sort of analysis, like rough analysis or detailed analysis, also including measurements. So the programs vary in this sense. Some programs do not offer support for analysis. Some offer support for rough first analysis, and some offer support in a comprehensive way for detailed analysis, including measurements on site. As for the evaluation of the programs, now you can see some program requirements, and these were actually perceived as limiting program effectiveness in the sense of the savings that can be achieved. So as mentioned before, the main funding criteria is cost effectiveness of the programs. And here you see a lot of data. The point here is really that there are many different requirements for the subsidy per end user, duration of the program, budget of the program, budget share for the program management, training, communication, and monitoring. Of course, the subsidy mentioned before, maximum 30% of the investment costs. And there is also a requirement that says that the support for the accompanying analysis cannot be more than 10% of the subsidy. And the result we found was that program managers tried to keep each budget position low. So meaning that they were trying to accommodate for the main criteria, the cost effectiveness of the program. And this resulted in the number of supported analyses declining. System optimization was actually targeted or done only in few programs, and means were missing for the training of the consultants involved in the programs who were accompanying the industrial end users with technical advice, and also limited means for program communication. Plus, at the same time, because there are many different programs targeting different aspects and target groups and technologies, for program participants, it is difficult to keep an overview. So instead of having like one central program for motor systems, there were different programs targeting different applications or target groups or sectors, as mentioned before. So the final conclusion is for the evaluation of the competitive tenders that they have come close to reaping the savings potential available within the framework of the program. However, this was more the low-hanging fruits than going really deep into the system optimization. Now, proceeding to key success factors. So for these 14 programs, we looked at what was really decisive in making the programs successful that have become successful. So now I would like to invite you for a second poll. Interested to know your views on this. Here some factors are listed. I can go through them shortly. So first, program focus, what I presented before, technology or target group specific program. Then the availability of support for analysis, whether this support is less or more. The funding level, is the funding level for the investment low or high? I mean, the funding level can be chosen. So the maximum is 30%, but it can be chosen by the program managers, what kind of funding is offered. Then the subsidy scheme, is it like a simple scheme, for example, X percentage of the investment costs, or more complex scheme? For example, also looking at the cost effectiveness of each measure. The program administration, the contact to potential program participants, is this a crucial factor? Or the other side of the coin, the program awareness among the target group, within the target group. The qualification of external technical consultants. I mentioned that that consultants were available for a number of programs, that these consultants were accompanying the end users in implementing the efficiency improvement measures. And last but not least, the additionality of measures. So what about the free rider effect? Which of these factors, in your opinion, is the most decisive for program success? You can choose more than one. You are free to choose. So we will wait a little bit until you can make your choice. And maybe a hint, I will present 5 factors on the coming slides. Okay, interesting. So if I see correctly, the program focus was mentioned as the most crucial factor. Oh, no, sorry, the funding level. Yeah, okay. The funding level, followed by program focus and subsidy scheme, plus the program awareness within the target group. Okay. Let's see, which is the fifth? Maybe the qualification of external technical consultants. Yeah. Okay. Now, success factors. The contact to the target group was factor number one that we identified. To give a little bit of more background, you can see this red table. There were different channels for the programs to reach their participants. So the first such channel were through technical partners like installers, manufacturers, vendors, service companies. Here, the limitation was that the buildup of these partnerships and let's say these channels to work in a successful manner, it takes time. Another channel was the existing network of consultants. As I mentioned before, in Switzerland, there is a voluntary target agreement scheme, and there are consultants who are active in this scheme, helping the end users enter into the target agreement and accompany them. So here, for example, this was one channel. And here the limitation was really the different level of know-how of the consultants concerning electric motor systems, which resulted in different prioritization of electric motor systems within a general audit, let's say. A third channel was, depending on program managers, the network of industrial clients. Some program managers had a network of industrial clients. Here, the limitation is that the expansion of this network is limited. The possibility for expansion is limited. So what we found is that the contact via whatever channel is an important factor. And this contact must be continuous, based on trust. And also, if there are consultants involved, a sufficient incentive should be there for the consultants to engage with the industrial end users and to follow through, meaning not only making the analysis, but also being there for implementing the efficiency measures. Now, the second factor, which is the other side of the coin, is the program awareness within the target group. So in order for a program to be successful, the rollout took some time. And as soon as the program got increasingly known, word-to-mouth propaganda among the target group, it was in greater demand. So this is just to acknowledge that successful programs indeed need a longer time horizon to be able to attract enough program participants. Other success factors, number 3, easy participation, meaning to make it as simple as possible for participants to join the program, meaning application, but also monitoring of the results, and really keep the administrative barrier low. Plus, this was mentioned as one of the key factors also during the poll, simple and easy to understand subsidy scheme. So this was based on the 14 programs. The experience in 14 programs is that X% of the investment cost can be determined easily, can be communicated easily. So this was actually one success factor. Then, of course, correctly mentioned during the poll, a sufficient financial incentive. It should be tangible. It should be high enough, something like 20 to 30% of the investment cost that helps to improve return on investment. And that is also like, it helps a little bit to bear with the burden of participation, the administrative burden of participation. And last but not least, this is actually a key point, is the qualification of the involved consultants. These consultants, they need to have sufficient expertise in electric motor systems and the ability to carry out analysis. These were the 5 most crucial factors that we found based on our evaluation that help in making a financial incentive program successful. Now, when we move to program design and building blocks of the program, I would like to show you some considerations for different aspects that can be looked at when designing a financial incentive program. So the first such aspect are, of course, the energy savings. What do we want to achieve? And here I distinguish between standardized measures and tailored measures. So standardized measures would be easy to implement, easy to monitor, well, standardized measures. And tailored measures, they would go more into the system. So looking at the complexity of the whole motor system, and therefore I call them tailored measures. So the difference is really, are we looking at the lower energy savings, the low-hanging fruits that are easy to reap, easy to collect, or are we looking at the higher energy savings, the system optimization, which is really a more complex issue. So other considerations or aspects are the cost per participant, both from the end user point of view, meaning how high is the investment that the end user needs to make, and from the program administration point of view, meaning how much does it cost for the program manager that one end user participates in that program. For the standardized measures, this is lower. For the tailored measures, this is higher. The same for technical complexity, for the necessary analysis, and of course, the necessary know-how to do these analysis and improve the motor systems. For standardized measures, this is lower. For tailored measures, this is higher. And in terms of the subsidy scheme, for standardized measures, this could be fairly simple, but for tailored measures, it could be more complex, and I'm going to show a few examples for that later on during the presentation. Ideally, this is my personal opinion, let's say, the subsidy compensates for the additional cost of the energy efficient solution. Also, I mentioned during the poll the additionality of the measures. So there is an evaluation of the free rider effect available. The source is quoted on my slide. There was an evaluation of other than our evaluation, like an external evaluation of the competitive tenders program in Switzerland. And this involved a lot more interviews than our evaluation. And both program managers and program participants were asked. Program managers said, well, around 23% of the program managers said that measures would have been implemented also without the subsidy. And for the program participants, this number is higher. So this is just to show that no matter how careful the program design is, the free rider effect just cannot be avoided. This is there, this is present. However, our analysis found that there is something else, which now I call the snowball effect, meaning that as soon as some measures were implemented and had a positive effect, other measures were implemented that were not planned before. So there is obviously a positive effect of these programs. And in the end, more savings are achieved than originally planned. Of course, we need to ask ourselves the question, what is the ultimate goal of these programs or of such programs? And a credo here or an appeal here is that financial incentive programs or any other policy instrument targeting electric motor systems should not go, let's say, for the low-hanging fruits only, but try to elevate to the system optimization level, not only improving one component, but looking at the whole system, focus on the largest potential, for example, all big oversized machines. And here is just a very simple calculation. If, for example, during an audit, 10% of the electric energy consumption of the enterprise is targeted, encompassing electric motor systems, and 10% of savings are found in these motor systems, then we have a total of 1% of savings compared to the whole electric energy consumption of that facility. However, if we widen our scope and say, okay, we want to go for the system, 30% savings, we do not target only 30% of the share of electric motor systems consumption within the total electric energy consumption, then we save 9% of the total electric energy consumption of the facility, which is 10 times more. So obviously, call to action, go for the system, not only the component, not only the low-hanging fruits. Now we move to building blocks of a program. In our study, we considered, let's say, 3 building blocks plus 1 roof. We call them 4 building blocks. So the first building block is a subsidy program for efficient electric motor systems. The second one is a utility program. The goal here is to involve and activate utilities, which in Switzerland is maybe a little bit a particular situation, because I will come to that later. The Energy Efficiency Directive does not apply in Switzerland. So there are no obligations so far for utilities. However, they will be introduced. And the third component is what we call an innovation program. Here, the idea is to promote innovation and technical progress through mass production and upscaling. So these would be 3 building blocks. They can be implemented individually or in combination. And the roof are the accompanying measures, meaning training, communication, availability of tools for program participants. So to give a little bit more details, the first building block, the subsidy program, we intended that for installed and new systems, for larger end users, older motor systems that consume considerable amount of energy, and typical measures would be efficient component, optimize the whole motor system to the requirements of the process, no standby consumption, and use of a variable speed drive. The second building block would be the utility program, meaning that utilities or electricity suppliers could offer subsidies for motor system optimization. And this could include progressive tariff reduction based on the savings achieved, free monitoring instruments, for example, smart sensors, remote control, and building up technical competence in the utilities themselves. The third building block is the innovation program, which is a public procurement program for equipment manufacturers. The idea is to decrease cost through economies of scale for innovative pump, fan, and compressor systems. And the public authority responsible for launching this program would also be responsible for launching a tendering process for the design and the production of these innovative systems. This idea was actually based on an Indian program. For the accompanying measures, they would entail both technical and administrative training, plus accreditation of trained people. For the communication, central points of contact and information campaign. And for the tools, this is both for technical and program administration. So tools would be available for both aspects. Now, I would like to invite you for our third poll. If you were to choose building blocks for a program, which ones would you choose? And you can choose all, none, one, or a combination. Okay. Subsidy program, utility program. Interesting. Innovation program on the third place, and accompanying measures. Apparently, only about half of participants to the poll would choose the accompanying measures as well. Well, maybe before we move on, here I just would like to say that I think I can speak for all authors of our study that we thought that accompanying measures are a must for the implementation of a successful subsidy program. Now we go for the modalities for subsidies. I see that the time is running quickly, so maybe we will have to skip one or two things, but we will try to do it well. So we have designed 5 different modalities for a subsidy scheme in this study. A is the type where we work with we suggest to work with a fixed subsidy rate. And then B, we have 4 different variants, B1 to B4, where we suggest to have a varying subsidy rate. There are some requirements in Switzerland. For example, the subsidy cannot be more than 40% of the total investment cost. And another important prerequisite, which is not given per se, but we said that this is an important prerequisite, is to have the soft measures, meaning the required analysis for optimizing motor systems, be included in the total investment cost. So the investment cost should not only be limited to hardware improvements, but also the analysis, the cost of the analysis and installation and well, yes, all other soft measures. So here is an overview of the different modalities that we proposed. For A, the flat rate, we suggest that the subsidy rate be based on the total investment or the additional investment cost. Additional meaning the more energy efficient solution compared to a standard or default solution. And the subsidy rate could be up to 40% of the total investment or up to 80% of the additional investment. For the varying subsidy rates, B1 to B4, B1, we suggested the subsidy based on the investment amount. So the subsidy would depend on the amount of the investment. Here are the 3 different investment categories between 10,000 and 100,000 euro, between 100,000 and 300,000 euro, between 300,000 and 1 million euro. And here the idea is similar to the flat rate concept, meaning 20 to 40% of the total investment would be the share of the subsidy, or 70 to 90% would be the rate of the subsidy for the additional investment. So of course, if the investment is low, 10,000 to 100,000, that would be the lower rate, 20% or 70%. And if the investment is high, that would be the higher rate, 40% or 90%. For B2, we define one category for the motor replacement, if there is only a measure for motor replacement. Here, the idea is that downsizing would be incentivized. So the subsidy rate would be calculated based on the nominal power of the new motor. For B3, system optimization, here we suggest to incentivize the system optimization. So this seems a bit complicated, but I will show a figure in a minute. Up until 30%, basically the subsidy would be the same as the level of the savings. So for example, if the savings are 1%, the subsidy is 1%. If the savings are 29%, the subsidy rate is 29%. And then this increment of the subsidy rate gets a bit, so it gets 0.1% for savings above 30%. I will go into the details on the dedicated slide for this. And B4, subsidy on company level, meaning if we look at the whole enterprise, then 20 to 30% of subsidies would be given, depending on the share of the savings by motor systems within the company. So these are the concepts that we developed. I will not go through each of them because it takes too much time. However, as mentioned by Fernando, there will be a longer version of the slides available on the website, and this longer version includes a dedicated slide for each of these modalities. So I will actually skip A and B1 and would like to show you B2 to B4. So we go to B2, the motor replacement only measure. As I said, the concept is to incentivize resizing. And here, we don't need to go into the details. The idea is really that, for example, if you look at the table, if we had a motor, an existing motor with 100 kilowatt rating, and this was exchanged with a 100 kilowatt motor, then the subsidy would be 15%. If it was exchanged with a 75 kilowatt motor, the subsidy would be 20%. With a 50 kilowatt motor, the subsidy would be 30%. So the smaller the motor, the higher the subsidy rate. For the system optimization, the figure shows it very clearly. So the idea is that there is an inclining subsidy rate up until 30% of savings. Why 30%? In the beginning of the presentation, I said that 20 to 30% are average savings that can be achieved on a system level. So up until 30%, this should be rewarded. And hence the subsidy rate equals the savings. From 30% onwards, this is more difficult to achieve. The subsidy rate has a positive increment of 0.5% per percentage of higher savings. So until 50% of savings, it inclines with 0.5%. Here you can see that. And once the savings are at 50% or above, it gets to a flat rate. This is also due to the fact that in Switzerland, the subsidy rate cannot be more than 40%. So the idea is a bit complex, but the idea is to avoid the system optimization. And finally, subsidy on the company level. So if you look at one company and the bundle of measures, then the subsidy rate would be increasing depending on how much savings would be targeted, given as a share of the total electricity consumption of the company. Now, this is the last poll, and I'm not sure how easy it will be to respond to this poll, but let's try. So I would like to invite you to give an opinion, if you have. If you were to design a subsidy program, which rate would you pick? And actually, you could also pick more than one or none. Which modality would you pick? The flat rate, subsidy based on investment amount, subsidy looking at motor replacement only, which could be combined with other types of subsidy modalities, the system optimization, or subsidy on company level. And I'm sorry, there is a mistake in the table, but I will correct it for the long version of the slides. Nice, system optimization is the first pick of those who gave an answer to the poll, followed by the modality for the motor replacement only, the subsidy based on investment amount, flat rate and the subsidy on company level. Well, thank you very much for your answers. It's really interesting to see what people think of these modalities. I will try to move. Yeah, we are running out of time, so therefore I will present this very shortly. Following this this feasibility study, actually, the decision so far is, I mean, there is no decision on going forward with one specific type of subsidy program. However, it was decided that Switzerland goes ahead with energy efficiency obligations for electricity suppliers, which was not present yet in Switzerland. And this is due to the fact that the Energy Efficiency Directive does not apply in Switzerland. So this is actually a new instrument. And I would like to skip the details. You can read it. It works, well, yeah, like an energy efficiency obligation scheme. What is interesting and what I would like to stress is that that the idea is, well, okay, maybe just briefly. So it should be launched from the 1st of January next year. It should contribute to the reduction of electricity consumption of the Swiss targets. It is for electricity suppliers, and 2% of their annual electricity sales volume is influenced by this instrument. No certification or trading platform is planned to be operated centrally. Now, what is interesting is that that this is an obligation. So it is not a subsidy that is not a subsidy program, or not. It is not foreseen that a subsidy is being paid. However, the measures for saving energy, including water systems, they should be measurable and quantifiable, and there will be a distinction between standardized measures and non-standardized measures. This I find a very interesting component of the program. And the energy efficiency measures may not be taken into account if their implementation is required by law, if they are eligible for financial assistance, or if they are not of a sustainable nature. So this is actually something that will happen soon, and it will be interesting to see how it unfolds and what results it will be able to deliver. For the conclusions of the presentation today, I would like to give you these thoughts as a key takeaway. So key factors of a successful program include, of course, several elements. What we identified was the contact or the channel for the contact to program participants, the awareness within the target group, easy participation, a tangible subsidy, and very important, qualification of the involved consultants. Now, program design depends on the objectives that we would like to achieve. And here are several building blocks that can be chosen for an overall program. The accompanying measures we find are a must. And the Swiss decision so far is to go ahead with an energy efficiency obligation for electricity suppliers, so far not including the subsidies, with standardized and non-standardized measures. Thank you. Open for questions.